All right, everyone, we're doing an adding and subtracting of rational fractions. And I'm going to change this word because Mr. Cole and I, we talked about it a little while ago, and we said, isn't that redundant? And then rational expressions.
I think it might be expressions on their sheet.
Okay, great.
Change that.
All right, so now we are going to basically we're adding fractions, and a lot of these fractions, that's what rational means, will have x and stuff in that. And if you remember back when you first learned fractions, you have to have common denominators. If you multiply and divide, doesn't matter, but adding and subtracting, you need the common denominators. You need common denominators. That is the key for these. Okay, so we conveniently already have a common denominator here, so I can just write my denominator, and I add the top. 3x plus 2x is
5x.
Okay. We must simplify this. The 5's cancel away because that's 1. And so I'm left with x. Let's try another example, shall we? Okay. This time I do not have a common denominator. So if I think about that, what is my common denominator going to be here, Mr. Cole?
Okay. Well, the lowest one we could use would be 8, wouldn't it?
Right. And so in order to get the 8, I'm going to multiply this by 4 over 4. Now, why can I do this? Does it change this value at all if I multiply by 4 over 4?
It's just like timesing by 1, isn't it?
Exactly. So it's going to make it look different. It's going to like change its close, but it's still the same kind of fraction. So if I multiply, I got 5m over 8, and then plus 4m over 8 as well when I multiply here and here. Adding my fractions, the bottom is the same, and the 5m plus 4m gives me 9m. Check my fraction if I can simplify this. 9 over 8 doesn't simplify, so that means I am done.
Nice.
Okay. The next one to consider, we need to get common denominator, lowest common denominator.
So 12 this time.
12. So in order to get that, I'm going to multiply this one by a funny looking 1, because it's just going to change the close. It's going to be the same value, but it's going to look different. And this one I'll multiply by 4 over 4. And so when the first fraction will be 9x over 12 minus 8y over 12. My denominator is just 12. Now, how do I subtract 9x and minus 8y? They're not like terms.
They're not alike, are they? So I guess we can't simplify it that much, but we can just write them together. So 9x minus 8y.
And that is the answer. I can't do any canceling or simplifying or anything. Done. Okay, one more to go.
Two more to go.
2 more to go, right. Sorry. Adding these together, my common denominator, I got x in there, and an x in here, and a 3 and a 2. So if I think about my least common denominator, or greatest common denominator, that's the better terminology, greatest common denominator, or least common multiple.
Least common multiple.
There we go. What am I going to do to these two fractions?
So we need something that you can divide exactly by 2x, and something that you can divide exactly by 3x. Right. So that'd be 6x, right?
Right, that'll be 6x. In order to get the 6x, I multiply this by 2 over 2, and this one by 3 over 3. So when I get it, the first term is going to be 15a over the 6x, which I have, minus 4a again over 6x. Now, would it be wrong, Mr. Cole, to multiply these two things together to get a 6x squared?
It would just make it more complicated at the end. We'd need to do some simplifying, wouldn't we?
Right.
It's just like with numbers. If you get the lowest common multiple, then you make it easier for yourself in the end.
Right. So if I had these fractions here, 1/4 minus 1/6, you could do a 24 denominator, but better is the 12 denominator. It saves you work later on. Your chances of mistakes are less. So think about it carefully first to get the least possible one. It's not wrong to get 6x squared, but your chances of making mistakes increase when you use that one. So let's scratch that one away. So when we do the computations here, the denominator is 6x, and 15a minus 4a?
11a.
11a.
And that's it.
Right, nothing simplifies, so that is the end. All right, so now...
We got one more difficult one, have we? With three fractions.
Ay caramba. And with these fractions, they all have different denominators. But what do you recognize about these two in this one? What do you recognize there, Mr. Cole?
Okay, well, I guess you can just make them all out of 3x, right?
Right. Make my common denominator 3x, and 3x, and 3x. Because we can see that if we multiply those two together, we get the 3x. So that's going to be the greatest common denominator here. So I know I multiply by x over x here.
Yep.
And this one 3 over 3. This fraction is not changed. Plus, this x here has to be multiplied in. Let's just write it as such for now. Minus, this minus sign is going to be a tricky one. This 3 also has to be multiplied in. So 2x plus 1 times 3. I'm going to put it all under one denominator of 3x. And so now I have 2 plus distribute this in. And so what do I get there, Mr. Cole?
So we got 2, add 8x, take away x squared. And should we carry on?
Yep.
We're going to do the same thing with the other fraction, right? So 3 times 2y is...
Oh, that's an x, is my bad typo.
So you got minus 6x. And then, well, this is confusing because you're going to... Maybe if you put the 3 at the beginning, it might be...
All right,
might be less confusing there, actually.
It is tricky. So this 3, we're going to move around, and we'll put it in the beginning.
Okay, so what we've done is minus 3 times 2x is minus 6x.
Right.
And now minus 3 times 1 is minus 3.
So we have to distribute the negative sign as well. That is a common mistake. Be careful with your positives and negatives.
Okay, can we tidy this up a bit?
Yes, we have 1 negative x squared. So negative x squared. We have an 8x and a minus 6x, which gives us plus 2x. And then finally we have minus 3 and 2, which is negative 1 over 3x. And that is fully simplified.